Right, like I was just saying in the previous video, the residual plot is another way that you can figure out that there are outliers. And I have this lovely picture for you right here. Namely, this is a scatter diagram, and you can see the outlier kind of up there on his own. In a residual plot, there's a residual plot. There he is, out there, outlier. Or you could make a box plot of said residuals, and you can see the outlier right there as a little star to the right. So that's another way that you can see outliers that you haven't had before. So for example, this is the revenues for the airline industry for various years. And you can see right there is a big old outlier, right? Far removed from the rest of them. So which year is the outlier? It's 2002. That point is far removed from the rest of the points in both the scatter plot on the left and the residual plot on the right. Okay. Would a linear model for this data be appropriate? Heck no. I just thought of this. Note that this year was unusually low in terms of airline revenue, in great part due to 9/11. The reason being 9/11 2001, right? It's towards the end of that year, so people that had flights up until that time still managed to they paid the airlines. But 2002, I mean, airlines just couldn't get people to take big trips, especially to foreign countries and such, for a variety of obvious reasons. Okay, would a linear model be appropriate for this? Heck no. No, right? Because there is a definite curved pattern to the residuals. Remember, pattern, bad. You don't want to see a pattern in your residual plot. Ignore the outlier because for obvious reasons that was kind of unusual, but look at the rest of them. Perfect, practically, a curve. So when you see a pattern like that, you should be doing something other than linear. Okay. What about influential observations? An influential observation is an outlier, but it's a special kind of outlier. It's an outlier that would greatly affect the slope and or the y-intercept of the least squares regression line. In particular, the slope. We're really interested in that. Okay. Influential point will be far away in the x direction, the explanatory variable direction, which is what the blue box says. But it also kind of wants to be off the path. So when you look at your points, they kind of form a path. And if the point that is an outlier is kind of on that path, then that's not really influential. So for example, this one, it's an outlier, but not in the explanatory variable way direction. Reason being, this red dot is right in the thick of these x values. Look, it's got an x value of about 3. Well, so do a lot of other points. So that's not really an outlier. I mean, it's an outlier in terms of the y direction, but that's not what makes it influential, right? All right, what about this one? This is an outlier for sure, right? Oopsie. Outlier, but not influential either. Oops, I suppose I should have written that. All right, this one is an outlier, but not influential because it's not far removed in the explanatory variable direction. Let me type these up. Hold on. Okay. So B is an outlier, but not influential because there's a path these other dots are making, and that red dot is right on it. C is an influential because if you look at the blue dots without that red point, you think of an upward slope. But once you put the red dot in there, it's going to cause it to tilt and have a downward slope. It's greatly affecting the slope. And it's off the path, and it's far removed in the x direction. So this is totally influential. This one, 2002, is not influential because you can see the two lines with it and without it, and they don't have a big difference in slope.